Wenjun. Today I'm with my group members Wenjun, Cheng, Lingtong to present you our Beijing air pollution ShinyApp. As the capital of China and a famous historical city that represents Chinese traditional culture, Beijing welcomes millions of tourists around the world every day. However, air pollution and haze has been a serious environmental problem in the metropolitan cities of China, especially in Beijing, for decades. This environmental problem has not only been increasingly threatening the health of Beijing residents and tourists, but also resulted in the decline of tourism industry. Our client, Imperial Travel Company, a leading travel agency based in Beijing, is jeopardized by the haze since it endangers the health of their customers and brings significant loss on daily operations. Imperial Travel Company needs to reduce the operation loss by identifying and avoiding danger areas in tour planning. Though there are many applications in the market that can predict air quality, Imperial Travel Company needs an application unique to their business. In addition to the company predicting the air pollution index of famous spots in Beijing based on weather conditions, customers will also have access to the tour. This will allow Imperial to schedule tour routes ahead of time for clients, and on the other hand, customers can customize their own routes based on the recommendations from the application. Thus, besides accuracy, this application needs to be easy to use and easy to understand. Now, Wenyin is going to talk about the analytics problem.
Wenjun. To address the concern and fulfill the requirements of our client, we need to develop a predictive model using no independent variables, such as temperature, wind speed, and the wind direction to predict the particulate matter index, also refers to PM 2.5. Understanding the relationship between weather parameters and the PM 2.5 index is the foundation for building this predictive model. We need to include the geography location as the predictors in the model so the prediction can visually display results of all famous sightseeing spots in Beijing. In this model, we assume that PM 2.5 index is only affected by and related to predictors in our dataset. We also assume that the PM 2.5, which refers to atmospheric particulate matter less than 2.5 micrometers in diameter, is the major and the most significant pollutants in the air. One of the key metrics of success is the accuracy of the model, and the final product, as required by our client, must not involve any technical terms and is acceptable by normal users. Now I'm going to pass it to Chen to talk about the data and the methodology.
The data. We collected air pollution data set in the past 5 years from 12 weather monitor stations around Beijing for the project. These stations cover all urban and suburban regions of Beijing, which gives us a comprehensive and detailed observation of the city air quality. The merged data set have 18 columns and more than 400,000 observations. 15 of them are numeric variables consisting of air quality indexes, measurements, and time variables. There are two categorical variables which consist of wind directions and the name of the station. Year, ID, and PM10, which is a variation of the PM 2.5, were dropped for lack of relevancy and redundancy. We also convert the two categorical columns into dummy variables in the analytics stage. Observations with the missing values were then dropped from the dataset. The final dataset has around 380,000 entries and 37 columns. For descriptive analysis, we use the line chart, histogram, calendar plot to show the variation of PM 2.5 by hour, day, week, month, year, and station. For predictive analysis, we apply several approaches to generate the most accurate models, such as linear regression, random forest, XGBoost, and auto machine learning. In the end, linear regression gives us the best result. Now, I will let Lingtong talk to show you the ShinyApp.
First version of the ShinyApp to predict weather conditions. Shiny is a web applications framework for R. In a nutshell, this means that anyone who knows some R can start to build applications that sit in a web browser. It could be as simple as displaying some graphics and tables to a fully interactive dashboard. Also, Shiny allows us to create true data products that go beyond standard business intelligence dashboards. We can define intuitive interfaces that allow business users to perform what-if analysis, manipulating parameters that enable them to see the impacts of different approaches on business outcome. Then I'm going to show you our interfaces of our Shiny applications. This is our information page, which will give a general view of our applications to the users and some really details about the versions and the context info. Next, let's go to our first tab, which is descriptive. In this tab, we'll let users to choose different stations and different years. This will give users 3 graphs about our descriptive statistics of the database. The first graph means a calendar graph. This shows the different PM 2.5 values by different days. As you can see, the darker the rectangles means the higher PM 2.5 values. The next graph shows an overview PM 2.5 values by hours, month, and weekdays. As you can see, one significant trend is that the weekend PM 2.5 values is significantly bigger than the weekdays. And the red shades in the graphs mean that the confidence interval about the PM 2.5 values. The last page is about the details info about PM 2.5s by different factors for users. And the red graph means a histogram about PM 2.5. So let's move to maps and predictives. In this tab, we'll allow users to predict the PM 2.5 values by preset factor values. For example, I want to see tomorrow's weather in Beijing to adjust my flight plan. In this bubble is the location of Beijing Capital International Airport, and it's in ShinyApp district. So in our right tab, we'll select the date for tomorrow's and enter hours, temperature, pressures, and all the factors values. And after change station to ShinyApp, we'll get a value for predictions at 31.52. Since this is an interactive interface for predicting weathers, we can adjust our factors. For example, I want to change the temperature to 15, and this will give us a different value for PM 2.5 predictions, which is 30.98. And also, we make this tab a absolute panel which can move everywhere, so the user can have a better view of the map. And the map can also adjust it and zoom in for zoom out for really details about tourists. The next tab is about data tables. This is our built-in database views, which will give users a specific view of our database by different column and different rows. For example, users can search here for different values, and if they want to see different columns for some reasons, they can uncheck the box for number. For example, the number column just gone, and do more applications. So this is our first version of the ShinyApp. So if you have any improvements and recommendations, just contact us, and we'll make our application better and better for the use. Thank you so much.